And welcome to Backspace Academy, and welcome to the AWS Certified Associate course. If you've just joined us, you've just made the very first step in an exciting and rewarding career in Amazon Web Services. So we're going to start off with having a look at this massive AWS global infrastructure, and then we'll discuss what actually is cloud computing and what are the cloud computing models that are available for us to use. And then we'll go on to discussing serverless computing, be able to deploy compute capacity without having to worry about having servers in the background doing that for us. Then we'll look at the different options that are available for deploying on the cloud, and we'll look at the AWS service categories. And there's a lot of them, and there is a lot of AWS services. And then finally, we'll finish up by having a little bit of a hands-on use of the AWS Management Console. The AWS global infrastructure is massive. It consists of 16 regions located across the globe, 42 availability zones, and well over 50 edge locations. Now, your choice of region can depend on a number of things. For example, you may want to give your end user the best user experience by having the most optimized latency. For example, if you're located in Brazil, then you would probably want to use the São Paulo region, because that's going to give your end users the best or most optimized latency to access your infrastructure. But that said, there may be other reasons why you want to use a different region other than the region that you are located in. For example, I'm located in Australia, in the Sydney region, but I mostly use the US East 1 or US East Standard region. The reason for that is that that region has significantly lower cost for me than the Sydney region. So not all regions cost the same amount. They do vary according to region. Another reason for me to use the US East Standard region is that I know that that region fully supports the broad offering of AWS. Whereas if I'm looking at something like the Mumbai region, which is a brand new region, that doesn't support all of the AWS services. So a lot of times you can get stuck if you're developing a solution and then you get to implement that solution, you find out, oh, hang on, my Mumbai solution actually won't work because we don't have that service available within Mumbai. So you need to take that into consideration, and that's why throughout this course we use the US East Standard region predominantly. You may also want to locate your servers in a specific region based on regulatory or legal requirements. There may be a requirement that you have to have your servers located in your country, and for that perspective you may want to consider locating them within your country, or there may be the opposite, that may be a regulatory requirement that requires that you have to locate your servers outside of your country. So the choice of region is quite important, and there are a number of factors around that. All regions are divided up into availability zones. Some have more availability zones than others. For example, the US East regions have 3. And when we look at Mumbai, for example, that only has 2 availability zones. It's a smaller region and a newer region. So those availability zones within a region, they are insulated from failures in other availability zones. So what that does, it enables you to have very good high availability. It's good for disaster recovery, because if one of those availability zones goes down, if you have your infrastructure shared across those availability zones, the infrastructure that is located in the other availability zone will continue to operate. So it gives you good redundancy and reliability for your infrastructure. And a lot of services out of the box support multi-availability deployment. For example, the relational database service does that very well. We also have 50 or well over 50 edge locations, and they are for the CloudFront service. Now, what CloudFront is, it's a caching service for Amazon Web Services, and it gets your content, your regularly used content, in a CloudFront distribution and it locates it specifically at these edge locations. So what that means is that you are going to get really high performance delivery of your content through to your end user. It's also going to save you server costs, because that content that is regularly accessed and doesn't change that much will be delivered immediately to your end user and won't even go anywhere near your servers unless that changes. So the CloudFront caching of data is a very important and very useful feature of AWS as well. Now, before we get too far ahead and start discussing all about Amazon Web Services, I think we need to ask the question, what is cloud computing? What is this whole cloud thing all about? And if you ask that question to a number of people, they generally get stumped if they haven't thought about that answer. And they'll generally come back and say, well, the cloud, it's internet. The cloud is the internet. It's that interweb thingy, which is not necessarily correct. Well, it's actually not correct. So I think one of the best definitions for cloud computing comes from Wikipedia. And that simply says that cloud computing, it provides shared computing processing resources and data to computers and other devices on demand. So Amazon Web Services has a massive amount of computer processing resources located across the globe, and databases and data storage, and that is available to computers and other devices on demand when needed. And it is shared across all of those literally millions of users. And by doing that, the costs involved in using these IT resources is significantly reduced because it's shared across millions of people. AWS also has its own definition of cloud computing, which is similar but slightly different. Cloud computing is the on-demand delivery of compute power, database storage, applications, and other IT resources through a cloud services platform via the internet with pay-as-you-go pricing. So it's pretty well the same definition, but it mentions that it goes through a cloud services platform with pay-as-you-go pricing. And that is very good if you're talking about AWS or Azure or any one of these commercial cloud offerings, but it doesn't really explain a private cloud. So you can actually create your own private cloud using your own pool of resources, and you don't need to actually use a AWS or any other service provider to do that. So that's really what cloud computing is all about, and it's not just the internet. Cloud computing is where we pull together computing resources and share those resources on an on-demand basis to multiple users. There are a number of models available for cloud computing, and they vary from very low level and nuts and bolts models right through to very high level and abstract models. Now, the first one there, the low level nuts and bolts model, is the infrastructure as a service, and that contains the basic building blocks for cloud IT. So we're going to grab these basic building blocks and we're going to piece them all together and link them all up, and we're going to create a solution. And a good example of that is the AWS Virtual Private Cloud that creates a virtual private cloud and all of the routing and so forth within that, and the security within that. We can also have the Elastic Compute Cloud, or EC2, where we can create Linux servers or Windows servers or whatever servers we want to create, and we can launch them within our VPC. And we also have Elastic Block Storage, which is storage that we can attach to our EC2 instances. So we can use this to piece together an end solution. And so don't be too concerned about whether you don't understand what VPC, EC2 and EBS is. We're going to discuss this further on in this lecture and in very much more detail throughout the course as well. The next model is the Platform as a Service, or PaaS, and that is where AWS manages the underlying infrastructure, which is usually the hardware and operating system. A good example of that is where you want to deploy a database, for example. So you could use the EC2 service and create a building block using EC2 inside of VPC and have an EBS attached to it and whatever. And then you can put your application, your database application on top of that server, and you manage that server, you manage that operating system, you manage that database. Or you could use something like the RDS platform as a service. So the relational database service, or RDS, that will take care of the basic building blocks. It'll take care of the Linux operating system. It'll take care of the EC2 instances. And you really just need to worry about the database itself. And so that's a step above from using EC2 to manually create a database solution. Another example is Elastic MapReduce, which is AWS's Hadoop platform as a service. And AWS Elasticsearch, which is AWS's Elastic.co Elasticsearch platform as a service as well. The next one is far more abstract, and that is software as a service. And that is where a completed product that is run and managed by the service provider, and mostly refers to end user applications. So there's some example of that if you are using web-based email, where you go to a browser and you access your email. That is a software as a service. You don't need to worry about what's behind that. You just use it as a service. Another very good example of a software as a service is Microsoft Office 365. Another one is Salesforce.com, where you can use these applications and use them as a service and deploy them as a service without having to worry about what is behind those, not having to worry about the architecture and the operating systems and all of that behind these services. Another concept that we need to talk about is serverless computing, and that allows us to build and run applications and services without thinking about servers at all. And that kind of sits somewhere between platform as a service and software as a service. So although it is quite abstract and high level, you still can create an application on top of that. So it's not fully a software as a service, it fits somewhere in between there. And it's also referred to as a function as a service, or abstracted services. Some good examples of that are the Amazon Simple Storage Service, and we'll talk more about these services in the next few slides. AWS Lambda, which is a service where we can just give our code to AWS and it will run that code for us and bill us in 100 millisecond increments. So we don't need to worry about anything other than just supply our application code and Lambda will run that for us. Amazon DynamoDB is a serverless computing NoSQL database. We just create a table for that database and AWS looks after everything that is needed to run that database for us, and it worries about everything for that database and the support of that database. Amazon Simple Notification Service is another serverless environment where we can send messages to different devices. We can send push notifications to mobile devices, and we don't need to worry about what's behind that SNS service. There are a number of cloud computing deployment models, depending on whether we want to deploy 100% to the cloud or whether we want to take advantage of existing on-premises infrastructure as well. So the first one there is a fully cloud deployment, and that's where everything is fully deployed in the cloud and all parts of the application run in the cloud. We have a hybrid solutions where that is connecting the infrastructure and applications between cloud-based resources and our existing resources that are not located in the cloud. We also have an on-premises solution, which 100% on-premises we're not going to be discussing other than here in regards to the AWS certified exam. And that is where we have 100% of our cloud computing deployed on our own infrastructure. So that is deploying resources on premises using virtualization and resource management tools. And that is where we call a private cloud, where we use our own resources, we pool all those resources together, and we use a virtualization model to create our own cloud, or our own cloud computing on-premises private cloud. Now, if you go to the AWS homepage at aws.amazon.com, and you should already have gone to that homepage and should have already have created an AWS account. But if you go back to that homepage, you can see, if you click on products, you'll see that the offering available from AWS is absolutely enormous. And when you're not exposed previously to AWS and you look at that, you think, wow, where do we start? So we're just going to run through the different categories there, and we can see that the categories are divided into compute, storage, database, and a whole heap of other different categories. We're just going to go through those categories now and look at some of the services that we'll be using within those categories within the course. The categories that I'm going to concentrate in this lecture are the compute, storage, database, networking and content delivery, management tools, security, identity and compliance, messaging, and the analytics category. Now, there's a lot more. So we've also got, on the right hand side there, you can see we've got application services, we've got migration, we've got developer tools, mobile services, Internet of Things, business productivity, desktop and app streaming, game development, artificial intelligence, and that list is growing all the time. But I'm just going to concentrate on those categories on the left that are most relevant for an associate level certification. Now again, one thing to consider here is that the AWS service offering is rapidly expanding, and you know, it's always a good idea to check the availability of a service in your particular region. For this course, we use the US East 1 standard region, simply because that is the main service that has the broadest range of AWS services available to it. If you're using, for example, Mumbai, that's a very new service, and so it's not going to have all of the services available for it. But if you just go to that URL there that is on the screen, and you can check the availability of a service in a region before you start working on your application. Okay, so now that we've got the theory out of the way, we've got the boring stuff out of the way, we can start to use Amazon Web Services. So the first thing we need to do is to create an AWS account. So go to aws.amazon.com and we click on Create an AWS account. So then we just put in our email address and click on I am a new user and go through the sign up process, and we will create an account. Just looking at this page here, we've got on the right hand side there, AWS accounts include 12 months of free tier access. So that's something that you need to keep into consideration, that if you use these resources, if you keep track of your free tier access, you're not going to get a bill at the end of the month. So I'm going to show you how to do that. So for now, just go ahead and sign up for AWS, and it's not going to cost you anything. So once you're signed up for AWS and you've got your account all established, you can go back into the homepage, select My Account, and then go to AWS Management Console. Now your management console might look a little bit different. If you've never used AWS before, there might be a welcome page there. So I'm just going to give a very brief overview of the user interface for the management console. So on the left-hand side here, we've got the console home. So just click on that. Just click on that orange cube to get back to where we are here. We have the services menu, and we can see there that we have our services will be grouped according to compute, storage, database. But if we click on the right-hand side here, we can also list those alphabetically. I prefer to have them listed alphabetically, but it's up to you what you would like to do. Another thing that I find is quite handy is that we've got a pin button here. So if we're using any of these services quite regularly, we can drag them onto the toolbar. So for example, if we're using Amazon S3,
we can drag it onto there. If we're using RDS regularly, we can put that on there as well. Also, another thing that I would like you to take note of is here we have a menu for the region that we are in. So I'm in US East North Virginia, and please make sure that you are always in US East North Virginia also for this course. The reason being is that if you're in another region, that may not fully support all of the services, and you may encounter problems. So for example, if you're from India and you'd like to use the Mumbai region, by all means use it for your own personal use. But for this course, please don't use the Mumbai region because it's a new region and it doesn't support all of the available AWS services. And it does make it more difficult for me when you've got a question, when something goes wrong. So just next to that, we have the account menu. So we've got my account and organization. The one that I want you to take good note of here is the billing dashboard. So I'm just going to click on the billing dashboard. And that's what you need to keep an eye on quite regularly, because you don't want to get a bill at the end of the month from AWS unless you can avoid it. So on this account, I've been quite good. I'm going to get billed for 1 cent. Now, the reason is because I just use this account for doing labs and nothing else. So just the same as I'm getting billed 1 cent, you could do the same with your account. Just keep it to 1 cent or below. It's quite easy to do. All you need to do is just make sure that you check the billing and cost management dashboard regularly to make sure you're not going to exceed it. So it's one thing to have a current expenditure, but what the most important thing is to have a look at what our forecasted expenditure is going to be. So we can see here we have our top free tier services by usage. So keep an eye on that, because that will tell you what your forecast to spend if you continue with the usage as you currently are. So you can see there I've been using Amazon S3 quite a bit, and I've already gone through 61.9% of my free tier limit. So because I'm halfway through the month, if I continue to do that, I'm going to exceed that, and I'm going to get a bill from Amazon Web Services for that. It won't be a particularly big bill; it might be $1 or something, but it's something that needs to take into consideration and keep a track of. So that's about all I'm going to show you for now of the AWS Management Console. Because the best way to really use this is just to really get your hands on these services and start doing stuff. So over the next few lectures, we're going to be doing a lot of hands-on. The early part of this course will be very hands-on, because I believe that you really need to have that to fully understand the more advanced theory behind a lot of this stuff. So it's going to make a lot more sense if you already know how to launch a Linux server, you know how to create a SQL database and all this sort of thing. So these are the kind of short things and short exercises that we're going to do over the next few lectures. Now, before we finish this lecture, you would have noticed that when it started, or hopefully you would have noticed, when this lecture started, there would have been a message that said that there are resources available. So what you need to do is you need to click on the Content tab and download those resources for this section. And one of those is the Introduction to AWS Lab Notes. And what that will allow you to do is to sit back and watch the videos of the labs, and then grab your lab notes and follow through and do it yourself. And that way you're not going to get lost. So coming up, again, we're going to have some pretty good AWS labs that are going to introduce us to the AWS services. And we're going to, first off, we're going to create an Amazon S3 bucket and use that to store some files. Then we're going to go into something a little bit more advanced, and we're going to deploy a WordPress server on Amazon EC2. Then we're going to be sending some emails using Amazon Simple Email Service. And then finally, we're going to deploy a SQL database server using Amazon Relational Database Service. So I'll see you in the labs. And welcome back to Backspace Academy. In this hands-on introduction to AWS storage services, we'll have a quick look at the options that are available for storage on AWS, and then we'll have a look at one of those options, being the Amazon Simple Storage Service, or S3 for short. We're going to create a bucket from the AWS Management Console. We'll add objects to that bucket, and then we'll download those objects back from the bucket. And then lastly, we'll delete that bucket completely to make sure that we don't get a bill at the end of the month. So the storage options that are available for us on AWS, the first one being Amazon S3 Simple Storage Service. And that is one of the serverless or abstract services of AWS. And what that means is that we don't really know what is going on behind the scenes with Amazon S3. We know that there's obviously going to be a server, there's going to be hard drives, there's probably going to be elastic load balancers and all sorts of things, but we don't need to be concerned about that. So we just need to know that we can create a bucket on Amazon S3, we can put objects into that bucket never gets full, we can just keep adding objects to it, and we can delete that bucket when we don't need it anymore. The next service there is Amazon Glacier, which is long-term archiving of data. So for example, you might have data inside Amazon S3, and over time that data is not needed anymore. It's obsolete, or it's old versions of software or whatever. It might be accounting records, and you want to archive that over to long-term storage that is going to be quite low cost, and Glacier is very low cost, the lowest cost option of the storage services. And so you can do that, you can store that in Glacier. The downside though is that if you want to get it back again, it's going to take you about 3 or 4 hours to get it back and restored from Glacier back to Amazon S3. The next option there is Elastic Block Storage, or EBS for short. And so that is basically just like a disk drive. It's block storage. And just the same as you can attach a hard drive to your desktop computer, you can do the same thing with EBS. You can attach an EBS volume to an EC2 server on AWS, and that will allow additional storage for that server. The next option there is the storage gateway. And so what that is a high-speed link between on-premises storage of an enterprise and to AWS. So if you would like to have a backup solution for your on-premise data storage, then you could create a high-speed network between AWS and your on-site storage, and that will be achieved through the AWS Storage Gateway. The next option there is Elastic File Service, and that is very similar to connecting a NAS to your network at home. And so that, in a similar way, allows multiple servers to access the same file storage. The next one there is the AWS Import Export Snowball, and that is basically, for want of a better word, a portable hard drive. And it is one with very massive capacity. For example, if you had a off-site storage solution on AWS that you wanted to implement, and you had petabytes of data that you need to get into AWS, you can organize with AWS to get a AWS Snowball device sent out to you. You can upload your petabyte of data onto that Snowball device. You can send it back to AWS, and AWS will import that for you to whichever service you're looking at, for example, to Amazon S3 or to Glacier or whatever. Now let's have a look at using some of these storage options with AWS. So here I've got the AWS Cloud in orange, and inside of the AWS Cloud, I've got a VPC, or a virtual private cloud. Now that VPC is our personal private space within the AWS Cloud. So what that means is that someone wants to come in here, or traffic wants to come in here from outside our VPC, it will be blocked. It won't be able to access those resources within our VPC. Now, by default, all AWS accounts will have a VPC created, called the default VPC, created in each region. Additional to that, you can create more VPCs if you would like to. So within our VPC, we can launch EC2 instances or EC2 servers within our VPC, and we can attach EBS volumes to these EC2 instances. And that's very similar to the way we would just attach a hard drive to our desktop at home. And in a similar way, we cannot attach multiple EC2 instances to our EBS block storage. So you can't grab a hard drive at home and connect it up to 2 computers as a block storage device. It just won't work. So the way that we do have multiple EC2 instances accessing the one device is that we use the Elastic File Service for doing that. So the Elastic File Service, now that is not located within our VPC. That is located within the AWS cloud. For our EC2 instances to access that EFS share, they need an EFS mount target. And what that EFS mount target does, it allows the EC2 instance, that EC2 server, to mount that EFS share as though it was similar to an EBS volume, like it was block storage. And that's in a similar way that you would use a NAS or network attached storage on your network at home, for example. And so that is how we would use that for multiple EC2 instances to connect to the one device. We can also use the Amazon S3 service to achieve the same thing as well. So with the Amazon S3 service, again, it is located within the AWS cloud, as is the Glacier Vault as well. So we can have storage of files within our S3 bucket, and then over time, when it gets obsolete, it gets old data, it's accounting data that's from years back, and we want to have access to that if need be for auditing or whatever, we can archive that over to Amazon Glacier. But if we want to get that back again into our Amazon S3 bucket, it'll take us about 3 or 4 hours to do that. So there is a penalty for doing that. Now, because the Amazon S3 service is not located within our VPC, we need a way of connecting from our VPC to the Amazon S3 service. And that is where a VPC endpoint for S3 comes in. And that allows our EC2 instances to go through that endpoint and to access the Amazon S3 service. Now here's a quite common example where you would have a large enterprise and they would be looking to have a disaster recovery solution to use the AWS cloud for backup and synchronization of data that is in their corporate data center. And this is quite a common example because a lot of large companies will go for AWS as disaster recovery service first before going to migrate their applications and everything over to AWS. And it gives them an opportunity to get their feet wet first before they jump straight into AWS. So on the left-hand side there, we've got the AWS cloud. Over the right-hand side, we've got the corporate data center in blue. So we have some on-site storage, and that might be petabytes of data. Might be a very large amount of data if it's a large enterprise. We would like to replicate and synchronize that data in Amazon S3. Now, the first problem we're going to encounter is that to transfer this data, this petabyte of data, over to AWS, using conventional techniques, using a high-speed data link, using the internet, whatever, is going to be expensive and it's going to be slow. And so that's where the AWS Snowball device will come in. So we can get AWS to send out to us a Snowball device to our corporate data center. And then we can upload our petabyte of data to that Snowball device. And then we can get that Snowball device and we can courier that Snowball device over to AWS. And then AWS will grab that Snowball device and they will upload it for us into the S3 bucket that we've created. Now, once that data is there, it will need to be synchronized on a regular basis. So to do that, if it is again going to be large amounts of data that we're transferring, we need to have a high-speed link between our corporate data center and the AWS cloud. And that is where the AWS Storage Gateway comes in, and that provides that high-speed link to a corporate data center and our AWS cloud. Okay, so let's go and have a go at one of these services. First of all, we're going to use the S3 bucket. We're going to do something very simple. We're just going to create an S3 bucket. We're going to use the AWS Management Console inside of our browser, and we're going to upload some files to our S3 bucket. And then we're going to grab some files back from our S3 bucket. And then once we've done that, we're going to tear it all down and get rid of it to make sure that we don't get a big bill at the end of the month. So let's get into it. Okay, so here I am in the AWS Management Console. We select Services. We'll go to our Storage Services and select S3. And that'll bring us into the S3 Management Console. So if we don't have any buckets already created, we'll be presented with this welcome screen here. So the first thing we want to do is create a bucket, and we'll put in a unique bucket name. Now that bucket name needs to be unique across the whole of AWS. So you need to provide something unique. You can't use the same one that I'm using here. So just make up a bucket name and put it in there. And we'll leave the region as US East North Virginia, and we click on Next. So I'm not going to talk about versioning or logging or tags, because this is really just a very, very simple, quick introduction to the Amazon S3 service. So I'm not going to talk much about this, but we're going to get very much into this further on down into the course. So we'll just click on Next. And again here, we're not going to get too involved in the permission side of it. We'll just accept what is there, and it's basically restricting access outside of ourselves. So we just click on Next, and then there's just a summary there of what we've selected. So we just click on Create Bucket. Now that's just created my backspace -test -bucket. Now your bucket name will be something different to that. So that's how simple and easy it is to create a bucket to store objects, to store files on AWS. Very easy. So let's just click on the link to that bucket. And again, we've got no objects inside of this bucket yet, so we're presented with a welcome screen here. So we'll click on Upload. Now the easiest way to upload files is simply just to drag an entire folder over and drop it on the form there. So I'm just going to go to my Windows Explorer, and if you're in Mac, use a Mac equivalent or the Linux equivalent, and just drop a folder. And it doesn't have to be anything particular, but make sure it's something not too big, or you'll be there for quite some time for it to upload. And just drop that on that form there. And that will get that ready to go. And so we just click on Next to accept that. And again, we're asked about permission. So we're just going to leave it as private. We're not going to grant public permissions. We're not going to get too much involved in this at all. This is really a very simple introduction to get you used to using AWS. We'll click on Next. And again, we have different types of storage classes. Some of them are more reliable than others, and some of them are more expensive than others. So again, we're just going to select the standard storage class, and we'll click on Next. And then we have a summary of what we've selected. So we just click on Upload. And after a certain amount of time, that will upload for us. So that folder is now just finished uploading, and there I can see it is. So if I just click on that, and I can see that those files that are inside of that folder have also been uploaded. So I can also go the other way now. So now that I've uploaded these files to Amazon S3, I can look at downloading these files as well. So I'm just going to select one of these files. So this one here will be fine. And we select More, and then Download As, and that will download, or it will create a download link for that file. So if I click on that download link, then that file will download for me. So that's all I'm going to show you now for the Amazon S3 service. It's really just a very simple introduction to AWS and how the Amazon console works, but the Amazon S3 service it is quite complicated when you get into it. And so throughout the course, we'll be doing more and more and more and building on what we know. But the purpose of this is to get you hands-on and getting you used to using the AWS console. So a very important thing, now that we've created some resources and we're not using those resources, is to delete those resources. Otherwise, we're going to get billed for those resources. So the way we can do that is that we can go back into our backspace test bucket. So just click on the link up the top here. And then we can select that folder. We can again go to more, and we can click on delete. And that's deleted all of the files within that folder. So another thing we can do now is just to delete the actual bucket itself. So instead of clicking on the link to the bucket, I'm just going to click outside of that link in here just to select that bucket. And of course, we could have just emptied the bucket from here, but I just wanted to show you a different way as well. So now we'll just delete this empty bucket. And we need to type in the name of the bucket. And that's deleted that bucket for us. And welcome back to Backspace Academy. In this practical lab, we'll introduce you to the AWS database services. And we'll look at doing a hands-on exercise with one of those services, being the Amazon Relational Database Service, or RDS for short. We will be creating a MySQL database server instance, and then we're going to connect from our desktop through to that instance and have a look at a database that we created on that instance. And then we'll finish up by terminating that instance to make sure that we don't get a bill at the end of the month. So the database options that are available for us, the first one there being RDS, or a relational database, and that is AWS's SQL database engines that are available on a platform as a service. So what that means is that you might have a MySQL database, and AWS will look after all the low-level stuff for you. They'll look after patching of the operating system. They'll look up at updating patches for the database and that sort of thing. And you really just need to look after the high-level administration of your database. The database engines that are available to launch on RDS include MySQL and a number of variations of that. So we have the MySQL Community Edition, which is available on the free tier. We also have MariaDB, and we have Amazon Aurora. Now, Amazon Aurora is AWS's enterprise scale equivalent of the MySQL database, and it is not available on the free tier. We also have PostgreSQL, and we also have Oracle and Microsoft SQL Server database engines available to launch on RDS. The NoSQL option available there is DynamoDB, which is a serverless environment. So it goes one step ahead of, or one step above from RDS, in that you don't have to worry about anything to do with the database. You just create a table and AWS will look after everything else for you. And that is a very good solution for high-speed databases, in particular for NoSQL databases. Elasticache, and that is in-memory caching for databases. And what that does, it allows very high speed, very low latency access to data. And what it does, it will cache in memory frequently accessed data from your database. And when a requester wants that data, it will be delivered from in memory back to the requester with very low latency. And that is something to consider if you are looking at providing a large database that has a lot of regularly accessed data, and you need to have very good performance out of that. And it also allows you to reduce costs and the overhead on your back-end database. Amazon Redshift, now that is the data warehousing solution for AWS. And what that is, it is a PostgreSQL database engine that has been modified for use on AWS and modified to provide high performance with petabyte scale data. the AWS migration service, and that orchestrates and helps to streamline the migration of data from one database to another. That could be from on-premises to AWS, or it could be within AWS as well. But it helps to streamline and helps to orchestrate that migration of data. Okay, so let's have a look at how we would use these database services in an example. So over on the right hand side there, we've got our corporate data center in blue with an on-site database. On the left hand side, we've got the AWS cloud in orange. Inside the AWS cloud, we've got a VPC, and again, that VPC is our own private space within the AWS cloud. Now, if we wanted to migrate our database from our corporate data center to Amazon RDS, then the first thing we would do is we would launch an RDS instance inside of our VPC. And so here we can see we've got an RDS Oracle instance. And once we've got that up and running, we can then look at creating, using the database migration service, a workflow or a job that will orchestrate the migration of that data from our on-site database through to our RDS instance. Once our RDS instance is up and running, we can start look at increasing the performance of that. So for example, just say that we were getting a whole heap of requests coming in all at once. How would we manage that? So we don't want to have any sort of complicated architecture that's going to be able to auto scale or whatever. That's not going to be available for us using the RDS service. So the best way to manage these spikes in demand, especially when there's spikes in demand from regularly accessed data, is to use Elasticache. And Elasticache will get frequently accessed data from the RDS instance, and it will store it in its cache. And so then those requests that come into the RDS instance, they will come into the RDS cache. If those requests, or if the information required is located inside the cache, it will just be sent back. If it's not, then that request will be forwarded on to that RDS instance. And that greatly reduces the load on our RDS database or our RDS server. And it provides really high speed, low latency access to our data for our users. So let's go and have a look at how we can use the RDS server. So we're just going to, inside of our default VPC, we're going to launch a MySQL database instance using the RDS service. Then we're going to do that using the AWS Management Console. And then we're going to connect into that MySQL instance using the MySQL Workbench application. And then once we're finished with everything, we're going to tear it all down and make sure that we don't get a bill at the end of the month. Okay, so I'm in the AWS Management Console now. We go to Services, to the Database Services and RDS. Now that will take us into the RDS dashboard, but if we don't have any RDS instances created previously, then it will go into a welcome screen like this. So we're just going to go to the left-hand side here, click on Instances, and we're going to launch a DB instance. Now we have a number of options available for our database engine. We have Amazon Aurora, which, as we said previously, is AWS's MySQL Enterprise Class database. And that is not eligible on the free tier, so we're not going to use that for now. And we have the MySQL Community Edition, and again they've got the Amazon Aurora. In case you missed it previously, they've put it up there, but we're not going to use it because it costs us money. MariaDB again is a MySQL compatible database, and again, if you missed it, there we have Amazon Aurora as well, which we won't be selecting. PostgreSQL, Oracle, and Microsoft SQL Server. So to make sure that we don't get a bill at the end of the month, we're going to click on this checkbox here saying free tier eligible only. And there we can see Amazon Aurora is not eligible for the free tier. So we go into MySQL, and we can see Amazon Aurora there is grayed out again. We can't select it, and we're going to select the MySQL Community Edition. And again, we make sure that we have this option here available. It says only show options that are eligible for the RDS free tier. We don't want to get a big bill at the end of the months. Now, if we scroll down, we have a number of options here. So the only one that we really need to be concerned with is the instance class. So we're going to use a dbt2 micro, which is a pretty small instance, and it's on the free tier. We don't have any other options for storage type other than SSD, where we're working on the free tier, so we leave everything there as it is. Now we go into the settings of our database server. So our database server needs to have a DB instance identifier. It needs to have a name. So I'm just going to call this one \intro-AWS. Now that needs to be unique within your AWS account for DB instances. Next, we're going to create a user, and I'm just going to call the master user admin, and I'll give that master user a password. Now that password has to be at least 8 characters long. So once we've completed that, we've put in our name of our database, we've put in our username for the master user of this database, or this database server, and we've put in our master password and we've confirmed that password. We click on Next Step. Now, we don't need to configure any of these advanced settings for network and security. We just leave the default settings as they are, but as we get more into RDS and other services later on in the course, we'll be getting more involved in this sort of stuff. But for now, we just want to get our dip our toes in the water or so with AWS. Now we have an option to create a database on launch with this database server. So we're just going to create a database called test. If we leave it blank, then there will be no databases on this database server, and we can create those later on. But we'll just have one ready to go, and we'll call it test. Now we don't need to worry about backups because this is just a lab. We're going to be doing it on the free tier. We just don't want to have any hassle with that. So I'm just going to change the backup retention period to 0, and that will mean that it will disable automated backups for the instance. We don't need to worry about monitoring or maintenance. We just leave that as it is. Again, this is just a hands-on introduction to RDS. And then we can launch that DB instance. After a certain amount of time, that will be acknowledged and we can view our DB instances. And we can see there that it has a status of creating, and after a while it will go to being available for use. Okay, so after a few minutes, or quite a few minutes, we've got our MySQL database server on RDS up and running, and its status is available. So the thing that we need to understand here is that we can now connect through to this RDS instance through an endpoint, and that endpoint is here. So we need to take note of that, and the part that we're interested in is the endpoint domain. So everything there finishing with amazonaws.com, and we don't do the :3306. We just select that. So I'm just going to select that now because we're going to be using that later on. Now, before we do that, we need some software to connect into our MySQL instance. So we need to go to the MySQL homepage, and there is a link in the lab notes to this to download the MySQL workbench and install it to our system. Okay, so here I am in the MySQL workbench, and down the bottom there we can see that we have the MySQL connections, and we don't have any as yet, so we just click on the plus sign next to it and we'll add our connection to our RDS instance. So we just give that a name. So I'm just going to call it backspace, that will be fine. Now a host name is going to be that connection string that we got, or that domain that we got from our RDS console, and it's not going to have the :3306 on the end of it. It's just going to have the domain details, the host name details, and the 3306 is our port number, which is already detailed there on the screen. Now, our username is going to be that master user that we set up when we created our RDS instance, and I used admin. And that is all we need. We just need a user, we need a host name, and we need the port that we're connecting on. So if we just test that connection now, it will ask for a password. And we've successfully made that MySQL connection. So we just click on OK and we can add that to there. So once we've created that connection, we can obviously connect into our database. So all we need to do is double click on that. And there we've connected into our RDS database. And we've got our MySQL or our SQL dashboard there set up. Now, if we look down here under schemas, we can see that we have that test database that we created or that we requested to be created in our launch configure, or when we're doing our configuration for our launch details of this RDS instance. So if we click on that information icon next to test, that will give us some information on that. Okay, and there we can see we've got our backspace database with a test schema in there. So our server backspace and our test database inside there. So there we have it. We've successfully created an RDS instance and we've connected into it using MySQL Workbench, which is pretty great. Now that you've successfully connected in using the MySQL Workbench, I'm going to show you how to connect in with the MySQL shell software, and that will allow you to do command line work, such as issuing SQL commands to your RDS instance. So the first thing we need to do is to install or download the MySQL shell, and there is a link in the lab notes to that URL to do that. Now when you get there, just scroll down, select your operating system. If you're on Windows, don't do this installer for Windows. It will install MySQL and all this stuff you don't really need. All we need is this 16.5 meg file down the bottom here. So just download that. If you're on a Mac, it will look something like this. So you will have a DMG archive that you can download and extract after you've downloaded. Okay, so now that we're in the MySQL shell, we can connect into our RDS instance. So the way that we do that is we do backslash, not forward slash, backslash, connect, and then we do our username, which was admin, and then we do @ and then we do that endpoint, our RDS endpoint. So we just jump back into the RDS console, we'll select that endpoint and copy it and bring it over. Now we don't have to worry about removing the :3306, we can leave it there, or we can take it off and it will default to 3306 anyway. We enter our password that we created, and that should connect us in a short amount of time. And there we go. Now what I'd like to do is just issue some SQL commands to the database. So I need to change to SQL mode. So again, we do \SQL. And I can issue a command now, so show databases. Now make sure that you put a semicolon on the end of your SQL commands, otherwise they're just going to hang there. And then we can see we've got our standard MySQL databases there, and down the bottom we've got our test database that was created for us by the RDS service. Now the test database will be empty. So I'm just going to select one of the system databases there, so the MySQL one will be fine. So I just do use, and then that schema or that database that I'm going to use, so MySQL will be the one that I use. And there we go, schema is set to MySQL. Now, when you do that command, make sure that you don't put the semicolon on the end of it, otherwise it'll hang again. Now I just want to issue another SQL command again so we can show schemas this time. Well, actually no, we'll show tables actually. And that will list the tables for the MySQL database. And there you go. So there's all those standard tables that you would have in there. So we've managed to connect in using the command line interface or the shell, MySQL shell, and we've switched over to the SQL mode and we've run SQL commands. So what we're going to do now is we're going to jump back into the AWS RDS console and we're going to delete all this to make sure that we don't get a bill at the end of the month. And back in the RDS console, we go to, or we first of all, we select our MySQL instance. We go to Instance Actions, and then we go to Delete. We don't want to create a final snapshot, and then we click the acknowledgement that we won't be able to get this back after we've deleted, and we click on Delete. And that will be deleting and eventually it will disappear from the screen if we keep refreshing the screen here. So there we have it. We've created that instance and we've connected in and now we're cleaning it all up afterwards. So I look forward to seeing you in the next lab. And welcome back to Backspace Academy. In this practical lab, we're going to introduce you to the AWS Compute Services. And we're also going to introduce the networking and content delivery services that are available on AWS. Once we've done that, and you've got a bit of an idea of the theory behind all this, we'll then do a hands-on exercise with the Amazon Elastic Compute Cloud Service, or EC2 for short. We're going to launch a Linux server, which will have an image of a WordPress application. And then we're going to use that to create a WordPress website. And we're going to access that website using our browser. And then once we're finished with everything, we're going to terminate it all to make sure that we don't get a bill at the end of the month. So the compute services are all about running code. And we can run code from infrastructure as a service right up to serverless environments. The first one there being EC2 or Elastic Compute Cloud. And that is infrastructure as a service. So we're going to be launching servers on the AWS cloud. And that could be a server running Linux, it could be a server running Windows. It could also be a server that has an application on it. For example, it could be a WordPress website that we would be launching on EC2. The next one there is the Elastic Container Service. And that is all about launching servers that have Docker containers. So the Docker container, it will have a container of everything that is needed for that server. It will have the operating system, will have the application, will have a whole heap of stuff there, additional to what you would normally have in a virtualized image. You don't need to know much about Docker for the associate level certification, but if you want to learn more about Docker, go to training.docker.com, but you don't need to know much about Docker. You just need to know that Docker containers are what I launched on the ECS service. We also have the Elastic Load Balancing Service, and what that will do is it will allow us to distribute requests that are coming in for multiple servers and distribute those requests across multiple servers and manage the load of those servers for us. We also have the auto scaling service, and that allows us to create an auto scaling group which we can launch instances into, and it will automatically add more servers if our demand increases, or it will reduce the number of servers if our demand on those services or on those servers reduces. And finally, there we have Lambda, and that is a serverless environment for running code on AWS. And that could be a NodeJS application, it could be a PHP application or Java or whatever, but it allows you to run code as a service and get billed in milliseconds for that. Sounds great, and it is a great service, but is not perfect. So if you're going to be doing something that has a lot of WebSockets or whatever, Lambda's not going to be able to do that for you. But it is great for example, if you've got an API and you want something that's going to respond to API requests, and that's where Lambda is great for doing that. And we've got there a deployment service as well, and that is Elastic Beanstalk. And what that does is it allows us to supply our code to the Elastic Beanstalk service, and then it will provision an architecture for that. And that will include elastic load balancers. It'll include auto scaling groups and EC2 instances. It'll do it all for us so that we don't manually have to do that. Okay, so let's have a look at how we could use some of these compute services. So we've got the AWS cloud there, and we've got the AWS cloud there in orange, and we've got a VPC, a virtual private cloud, in blue. Now the VPC, again, that is our own virtual private space within the AWS network. Within our VPC, we can launch an EC2 instance. Now that EC2 instance, it could be a Linux server, it could be a WordPress application, it could be a Docker container that we're launching within our VPC. So once that's up and running, it can receive requests from the outside world. What happens when we get a situation where those requests are getting too much for this EC2 instance to handle? So what would we do? And so in the olden days, back in the 80s and the 90s, the done thing was to tear this down and replace it with a bigger instance. So we would normally get to a point where the reliability of our web server was getting to a point where we would say, okay, we need to do something about this. It's creating problems for us. And we'd go to our accounts department, we'd put in a capital expenditure request, and a year later, maybe we might get a nice big new server, and we'd tear down the old one, we'd have a bit of downtime to do that, and we'd create this great big server. That was a done thing back in the 90s and the 80s, but we don't do it that way now. So the other option too, as opposed to vertically scaling, getting a bigger server, is to do horizontal scaling. So what that means is that we can scale out horizontally by adding more of these instances as we need them, which is great. And that allows us to also scale in, so we can reduce these instances if we find that all of a sudden our demand on that server has gone down for whatever reason. But what happens though if we're still getting these requests coming in? So we've got multiple requests coming in, and we've got multiple EC2 servers available to handle those requests. But our web server only needs one, or only requires one endpoint. We can't have multiple endpoints for our site. So how do we distribute these requests to these EC2 instances? And that's where the Elastic Load Balancing service comes. Now that Elastic Load Balancer, it will receive requests from the outside world into our VPC, and it will distribute those through to an EC2 instance that is in a best position to handle that request. So when another request comes in to the Elastic Load Balancer, it will distribute that through to another EC2 instance. And so what that does is it makes sure that none of these EC2 instances are unbalanced, so more overloaded than the other one. What it can also do is it can implement health checks. So for example, if this EC2 instance here becomes unhealthy and is no longer available, it will stop sending requests to that EC2 instance. But what happens if all of a sudden, at some point during the day, we get a big spike in demand for our web servers, and it's too much for this EC2 instance group to handle? And a good example that would be in a large organization at 9 o'clock in the morning, you switch on your computer, everyone switches on their computer, and you get a big spike of demand on your server. How do you manage that? It's not going to be practical to, at 8:30 in the morning to launch a whole heap of instances, and then at 10 o'clock tear them all down, and then before lunch tear even more than down, and then after lunch put more on. We need something that can do that automatically and dynamically for us, and that's where the auto scaling group will come in. So what we can do is that we can create an auto scaling group inside of our virtual private cloud. And what that will do, that will enable us to add, or the auto scaling group, it will automatically launch more instances for us when the demand on our instances increases. And when the demand on our instances decreases, it can scale in, it can reduce the number of EC2 instances. And so as time goes on and we need less and less of these instances, it'll start taking those out. And then it'll go back in and it will add more of those in. And that's very good. So for example, at 9 o'clock in the morning, it will scale up and it will add more EC2 instances for us. And then just before lunchtime, it'll scale in when the demand is not there. And after lunch, when the demand increases, it'll scale up again. And so that's how we auto scale, and that's how we introduce elasticity into our environment. So in the networking and content delivery services, the first one there is Virtual Private Cloud, or VPC for short. And that is creating our own private space within the AWS network. And every account on AWS will have a default VPC already created for you. And that will be in every region. And also you can create additional VPCs if you need them. The next service there is the AWS Direct Connect service, and that provides a high speed access and high bandwidth access to the AWS cloud. And that is very good for large enterprises that need a high speed, high volume connection to the AWS cloud. We also have the CloudFront, which is the content delivery network for AWS, and that allows us to cache our regularly used or regularly accessed content into a CloudFront distribution, and that will provide very high speed, low latency access to our data for our end users. The next one there we have is the Elastic Load Balancing service, and as we saw before, it's also part of the compute services as well, and that distributes requests to our servers and balances the load on our servers for those requests. And finally, we've got the Route 53 domain name service, and that allows us to route requests for our domain name through to our AWS services. So let's have a look at a networking example. So there we have our AWS cloud, and within our AWS cloud we have regions. So there is a region drawn in there in black, and we've also got availability zones inside of regions. So I've just drawn in there an availability zone in the dotted orange line. Inside of that availability zone, we've created a virtual private cloud, or a VPC, and that is located there in blue. And inside of our VPC, we've got an Elastic Load Balancer, and which is distributing requests from the outside through to our EC2 instances. Now, what happens if our availability zone goes down? If our availability zone goes down, our infrastructure goes down and we don't have access for our end users, which is not a good thing. So how do we manage that? So the way we do that is that we create a multi-AZ, a multi-availability zone environment. And what we can do is that we can create our VPC to span multiple availability zones. And what that will mean is that if one of these availability zones goes down, our load balancer will continue to receive requests and will continue to direct traffic through to the healthy availability zone. And if we've got health checks set up, then it can also cross load balance and distribute requests to additional EC2 instances that can be created if we have an auto scaling group. So if we find that our requests are coming in with great frequency for example, one single web page, it might be our home page, for example. Everyone goes to that, and we don't want to keep fetching that through our Elastic Load Balancer and from our EC2 instances and back out again. It's a good idea to sort that out and put it into our CloudFront distribution. So if that page, if for example it's our home page, comes in for a request for that, we can just send that straight back out from the CloudFront service. If a web page is not located in that CloudFront service, then it will go back out through to the Elastic Load Balancer. It will be fetched back out as before and back out through and out to our requester. And so that helps us to reduce greatly the load on our infrastructure, the load on our Elastic Load Balancer, the load on our EC2 instances. But at the same time, it's going to create very high performance for our architecture, and it's going to create very low latency for our end users. Now, we don't want to direct traffic directly to our CloudFront distribution because that will have a domain name that will be quite long and won't really mean anything. So if we got, for example, our domain name is example.com, we can use the Route 53 domain name service to route traffic through to our CloudFront distribution and on to and back out again to our end user. And if we've got a corporate data center that we want to connect into this AWS cloud, into this infrastructure, we can do that using the AWS Direct Connect service. And that will create a very high speed and very good quality connection from our corporate data center through to the AWS cloud. So let's have a go at creating a EC2 instance and launch it within a VPC and see if we can get it to receive traffic from the wider internet. So we're going to launch an EC2 instance inside of our VPC, and we're going to use an Amazon machine image, an AMI, that will contain the LAMP environment, and will also, which is Linux, Apache, MySQL, and PHP. And it will also contain a WordPress application. And that will allow us to go to the public IP address of this EC2 instance, and we will be served up a web page from that WordPress application. And we'll do that using the AWS Management Console. Okay, so in the AWS Management Console, we go to Services, we go into Compute Services, and we select EC2. Now that will take us into the EC2 dashboard. If you've never used EC2 before, you might be presented with a welcome screen, but just go to Instances on the menu here and click on Instances. And we're going to launch an instance. Now we first need to select an Amazon machine image or an AMI. And that is a template that contains the software configuration, the operating system, application server, and applications that are required to launch an EC2 instance. We can select an AMI provided by AWS from the AWS user community or from the AWS marketplace. Or we could also select our own AMI if we've created an AMI previously, which we obviously haven't. So we're going to go into the AWS marketplace and we're going to search for a WordPress AMI. So they're the WordPress powered by Bitnami. That will be fine for us to use, so we'll select that one. And we're going to select the T2 micro instance because it is free tier eligible, which means that if we create this instance and then we shut it down afterwards, we're not going to get billed because it's on the free tier. We have a whole heap of other options that we can do, but we're just going to go into the configured instance details, and the only thing that we need to change here is to auto assign a public IP. So we need to have a public IP address for this EC2 instance so that it can have a presence on the internet and so that we can access it through a web browser. Now, there are a whole heap of other options that we can look at, but this is really just an introduction to AWS. We're going to do something very simple and the most simple thing that we can do right now. We're not going to get into discussing any of this stuff because we're going to go into quite in-depth detail on the EC2 service and VPC and a whole heap of other stuff further through the course. So for now, we're just going to click on Review and Launch and accept everything that we've got there. And we just click on Launch. And instead of choosing a key pair, we're going to proceed without a key pair. And a key pair is used to connect directly into our EC2 server. And we're not going to be doing that, so we're not going to be connecting into the Linux operating system, but normally you would, and normally you would download a key pair and you would use that to connect into your Linux server. But for now, we're not going to do that. And we just acknowledge that we will not be able to connect to this instance because we don't have a key pair. And we launch the instance. So after a certain amount of time, it will go through its process and will be returned to the EC2 dashboard. And there we go. So we just click on View Instances, and our instance will come up with a status of pending. Okay, so after a few minutes, our EC2 instance status its instance state has changed to running. And that means that we should be able to see our web server on the internet. So if we've selected this instance and we look at the details for this instance, so we go down here and we can see that it has been assigned a public IP address. So when we're configuring our launch for this, we did select to create a public IP, and that is a public IP address that has been created. So if we go to that, we should be able to see our WordPress application. Okay, and there is our WordPress application, and looks great. So we can't really do much with it now because we need to be able to administer our WordPress application. We need to be able to log into this site and put web pages on it and whatever. So the people at Bitnami, what they've done is that when this EC2 instance launched, they created a username and password and they embedded that in the logs of our EC2 server. So when it was launching, there will be a number of logs that will output information. So we just need to go into those logs. So we'll go back into the EC2 Management Console. Again, we've selected our EC2 instance. We'll go to Actions. We'll go to Instance Settings. And we're going to get the system log. Okay, so there's the system log. If it first doesn't come up, you just need to give it a bit of time. Just go away, have a cup of coffee, come back, and the system log will be there. It doesn't automatically just come up straight away. Sometimes it does take a bit of a while to come up. So we just scroll down until we find the section where it has our details. So here we can see we're setting the Bitnami application password to that. So we just need to copy that password. So we just copy. And we'll just close out of this. Now if we go back into our user's blog, or into our blog there, and we just go to that IP address again and we go to admin. And that'll take us to the admin section, and we'll need to put in a username. So the user will be user, and then we just need to paste in that password and log in. Okay, so there you can see, we won't remember that password. So there you can see that we've logged into our administration page of our WordPress application. So we can do whatever we want. We can add some pages in here. We can go into pages, add new page if we want. We can do whatever we want as we would with any WordPress application. So that's how we launch an EC2 instance or an EC2 server to create a web server. Now that we've achieved that and we've created these resources, we're not going to need them anymore. So what we're going to do is we're going to get rid of them. We're going to delete them all and terminate these instances. So what we'll do is go back into the EC2 Management Console. We'll go into Actions, and then we're going to go to Instant State, and we're going to terminate that instance. And it's just giving us a warning saying that, do you really want to do this? Yes, we do. So yes, terminate. Okay, so after a certain amount of time, and it will take quite a bit of time, that will go from shutting down to terminated. So that's all that we need to do now. So again, there's a lot more to the EC2 service that you need to know. But for now, I think you've got a good idea of how it all works. So it's now your turn to go and grab the lab notes and do it all yourself, and I'll see you in the next one. And welcome back to Backspace Academy. In this practical lab, we're going to introduce you to the messaging services of AWS, and then we'll just have a very quick exercise in using the Amazon Simple Email service to send an email.
In the messaging category, we have Simple Queue Service, or SQS, and that is a serverless service for decoupling our applications from demand. What I mean by that is, for example, if we have an application that is processing messages or whatever it's doing, we can use the Simple Queue service as a queue in front of our application. So if that application all of a sudden receives a massive amount of demand, those requests for processing will go into the queue, and they will be built up in the queue until such time as our processing server is able to process that and reduce the queue size. So it's effectively decoupling our application from the demand by putting a queue in front of it, just the same as you would have a queue at the shopping centre or a queue at your local bank. The same concept. The next one there is Simple Notification Service, and that provides publish and subscribe messaging. And the way it works is that you would create a SNS topic and you would publish a message to that SNS topic. And anyone who is subscribed to that topic will receive that message. It can also be used for mobile push notifications. For example, if you would like to send from your application push notifications to an iPhone or to Android devices, you can do that through the SNS service. And finally, there we have the Simple Email service, which, as the name says, is for providing bulk delivery of email. So let's have a look at a process decoupling example. So on the right there, we've got some instances. And so those instances are processing messages as they come in. Now, if we have a situation where we have a massive spike in demand and we have a whole heap of messages coming in at once, then that will most likely crash our EC2 servers, which is something that we don't want to happen. So to decouple the demand from our process, we can put an SQS queue in front of those EC2 instances. So what that will do is that the messages will come in, and if there's a big spike of messages coming in, they will just build up into the queue until such time as the EC2 instances, they can just go through and process those. And the way they would do that is that the EC2 instances would poll the queue to see if there are any messages in the queue, and it will process those messages, and then after it's finished processing that message, it will delete it from the queue. And so all of a sudden we can handle these irregularities in our demand without crashing our EC2 instances. But that said, that is not really a perfect solution, because we could have a situation where we just didn't have enough capacity in our processing instances to handle the average demand. And when we have a situation like that, the SQS queue will just grow and grow and grow indefinitely into such point that the SQS queue becomes overloaded and crashes. So we don't want that to happen. So what we can do is we can use an auto-scaling group, and we can launch our instances within an auto-scaling group, and we can have a CloudWatch metric from the CloudWatch service that can trigger an alarm to scale out or scale in. To scale out by adding instances to increase our processing capacity, or scale in by reducing instances and reducing our processing capacity. And by doing that, we are going to have an optimized solution, an optimized from performance and optimized from cost as well. So the way we would do that is that we could set up a CloudWatch metric that would be based upon the length of the SQS queue. So if we get to a point where the SQS queue builds up too much, then we can have an alarm that triggers an auto-scaling event to scale out and add instances to our auto-scaling group. But at the same time, we don't want too many instances when the demand goes down. So we can set a lower set point that will trigger a CloudWatch alarm when the queue is empty for a significant amount of time, and then we can set that to as an alarm to the auto-scaling group, and the auto-scaling group will reduce the number of instances. So that way we are not only managing spikes of demand, we are also matching from a long-term perspective the performance of our instances and the capacity of our process. We're matching that really very well to our demand, and it's going to give us the best performance and the lowest cost solution. Now that said, what happens if, for example, we've made an update to our application code and it has a bug in it and it's not processing those messages properly? In a situation like that, it doesn't matter how many instances we add, the SQS queue will still continue to grow because the messages just aren't being processed because there's a bug in the application code. So we can set an even higher set point in our CloudWatch metrics. So when the SQS queue gets really high, we can have that send an email notification to our administrator, and we can use the SNS service to do that. It will send a notification as an email, and then our administrator can come in and investigate the problem. And so that's what we talk about with a process decoupling service or a process decoupling architecture, and it's quite common that we would use something like that with AWS.
In the AWS Management Console, we go to Services, and over on the right hand side here we've got Messaging Services. We click on SES. And the first thing we need to do is that we need to verify our email address. So we just go to Email Addresses, and we'll put in we click on here to verify a new email address. And then we click on Verify this email address. So what's happened now is that AWS has sent an email to us to verify our email. Once we click on that link, we'll be able to continue to use the SES service. Okay, so when you've clicked on the verification link to the email, you'll get a congratulations message that you've verified your email. So just click out of that and go back into the SES Management Console. If we refresh the screen, we can see that it has now been verified. So what we can do now is we can send a test email. So just click on Send a Test Email. We'll put in, what I'm going to do is just send a message from myself to myself so that I don't have to verify any further or any additional email addresses, and just put the subject as test. Let's copy that over, and we'll send that test email, and that will be happening. And so what we can do is we'll go into our email account and we'll see that that test email will have been sent. Okay, so I've just gone and checked my email account, and yes, that test email went through fine. Now, you might be questioning, what do we do now? It's one thing to send a single email, but that's not much good to us. We want to send out bulk email. Now, obviously, sending out bulk email it can be spam. So AWS are mindful of that, and so there is a process that you have to go through to apply to use the SES service to send out bulk email. So the way you do that is you go into just go into sending statistics here, and you can see there is a link there to request a sending limit increase. So just reading off there, so your Amazon SES account has sandbox access in region US East Virginia. And so that is very limited to what you can do. And so if you're going to be using this for example, in an enterprise application, then you would want to go there and request a sending limit increase. And so just click on that, and it'll take you to a form that you fill out with all your details, and you just submit that to the AWS support department, and they will make that happen for you. So that's all I need to show you now on the SES service, and I look forward to seeing you in the next one. Welcome back to Backspace Academy. In this practical lab, we're going to introduce you to the management, security, and analytics services of AWS. And then we're going to use one of these management services, the AWS CloudWatch service, to create an alert whenever our bill is estimated to exceed a certain limit.
In the management tools category, one of the tools that we'll be using quite a bit will be CloudFormation, especially if we are a SysOps administrator or a developer. And what CloudFormation does is that you can write a JSON document or a YAML document, effectively a text file, and you can define exactly what your architecture should be. So you can define a virtual private cloud, you can define EC2 instances and all this sort of stuff, and you can define that in a file. And then the CloudFormation service will grab that CloudFormation template, it will create a CloudFormation stack which will deploy all of those services for you automatically. The big advantage of that is that because we are now defining all of our infrastructure in a JSON or a YAML document, we can use Git or any other version control system to manage that document. And all of a sudden our infrastructure will be treated in the same manner as we treat our code. And so if we want to make an update, we update our YAML or our JSON CloudFormation template and we redeploy our infrastructure. If we have any issues, we can go back to a previous version and roll that back if we have any problems. So it's very similar to what you would do when you're developing software and rolling out updates to software. You can do the same thing with your infrastructure. Another area that we're going to be using quite a bit, or another tool that we'll be using, is CloudWatch. And that provides monitoring of our services. For example, if we have a server, we could monitor the performance of that server, and we could give off alarms that would alert us to problems if that server goes down or if that server becomes overloaded. We can also use CloudWatch alarms to trigger an event for an auto-scaling group. So if the EC2 instances are getting overloaded within an auto-scaling group, then CloudWatch can send an alarm to the auto-scaling group to launch more instances. And we can also set low set points for CloudWatch, so where the demand on these EC2 instances, for example, goes below a certain level, then we can also use that to trigger an alarm for an auto-scaling group to reduce the number of EC2 instances we have. We also have OpsWorks, and that is another deployment tool like CloudFormation, but it uses chef recipes. It doesn't use a JSON template, it uses chef recipes for deployment of that infrastructure. You don't need to be an expert in Chef for the AWS Certified Associate course, but if you want to learn about Chef, go to learn.chef.io and there's some very good resources there on that. But again, you don't need to know Chef to pass the AWS Certified Associate exam. You just need to know the basics of OpsWorks and understand that Chef is what is driving that. We also have CloudTrail, and that is a really good service for security and auditing perspectives. What that does is that it continuously monitors all of the API calls in our infrastructure. So for example, if we have a situation where we have an attack that has come through our firewall, or if we have an attack that has come from within our infrastructure from, for example, a rogue employee, we can continuously monitor what is going on. So anything that happens in the AWS console, for example, if you launch an EC2 instance using the AWS console user interface, that will send an API call to AWS for that to happen, and that will be picked up by CloudTrail. So if you find that something suspicious is happening, you can react to that, and you can also set up, you can integrate that with CloudWatch, so that it can provide alarms that can alert you to any security issues that may have occurred. Also, after an event, if you want to look at what happened after a security event occurred, you can look at the CloudTrail logs and see exactly what happened. Another management tool there is the Trusted Advisor, which is an expert system provided by AWS. And what it does, it will run a scan of your existing infrastructure and it will advise you on things to change. It will advise you on areas of performance. It will advise you on areas of costs. It will advise you, of course, on areas of security. And if you go through and use Trusted Advisor, it's a very good tool because there might be something that you haven't picked up on, and then you can take corrective action to close that gap. Now, the most important category of all being the security, identity, and compliance. The main one there is the Identity and Access Management Service, or IAM, and that is how we manage access to our AWS account. So we automatically, when we create an AWS account, we have a login for our AWS account, being a root login. So that provides unlimited access to our AWS account, and we don't want to use that. So what we do is we create different users that can access our AWS account, and we have fine-grained control around the permissions that they have within our AWS account. So we can create multiple users with different levels of permissions. We could have a general user, or we could have an administrator user. We could have a finance user that would only have access to our finance area. And we can do that all using our Identity and Access Management Service. We can also group these users into IAM groups. And we can also have roles that can be used by EC2 servers that can allow them to access different areas of our AWS account. The next service there is the AWS Directory Service, and that looks after authentication of third parties that want to access our AWS account. For example, you might have a mobile application that has millions of users, and those users need to upload files to Amazon S3 or something like that. Now, that's not going to be practical to do. You're not going to be able to create millions of users using identity and access management. It's just not going to be able to be done. And even if it was able to be done, it wouldn't be practical at all. So the AWS Directory Service can use, for example, AWS Cognito, and that will provide an authentication service, and that can be integrated with other authentication services such as Facebook or Google. And so we can authenticate our users based upon that, and then the directory service will manage the permissions that are defined for that. We could also use the AWS Directory Service as a service for Microsoft Active Directory as well, and we can use it for linking between third-party LDAP directory services as well. The next one there is the Certificate Manager, and that enables us to be able to create SSL certificates so that we can have HTTPS encrypted traffic to and from our websites. And we also have the Encryption Key Management Service, or KMS, and that is a secure service for managing our encryption keys that we use for encrypting our data that may be in data stores, or could be in S3 or whatever, and we can use those encryption keys and make sure that they're safe by using the KMS service. And finally there we've got the Web Application Firewall, or WAF. Now that is a firewall layer that we can put in front of our infrastructure, and that is additional to the firewall settings that we would set up in, for example, our Linux operating system, and also additional to our EC2 security groups, which are also similar to a firewall. So this is an additional layer of defense that we can use for our applications. The last category that I want to talk about is the analytics category, and the areas that we need to understand for a associate level certification is AWS Elastic MapReduce, or EMR, and that is AWS's Hadoop as a service. And Hadoop is an analytics service for analyzing large amounts of data. If you want to learn more about Hadoop, just go to hadoop.apache.org and you'll learn all about Hadoop. You don't need to be any particular knowledge of Hadoop for an associate certification. You just need to know the basics around Elastic MapReduce and understand that Hadoop is operating to make that happen. And we'll talk more about that later in the course. We have Elasticsearch, and that is the Elastic.co's Elasticsearch application, which has been provided on AWS as a service, and that gives you search engine capabilities for your applications. We have Amazon Kinesis, which is a very rapidly growing service, and that enables us to collect real-time data as streams and analyze that also in real time, which is really quite powerful, especially when you start talking about things such as internet connected devices and Internet of Things applications, where you're collecting a large amount of data on a real-time basis, and you may want to have access to that data in real time. Amazon QuickSight, which again can integrate with Kinesis to provide data visualization, and it can also be used with static data. If you've got data in, for example, an S3 bucket, you can visualize that data using Amazon QuickSight, and it's very similar to the way you would use Tableau, or if you're a Java programmer, the way you would use BERT for visualizing of data. But it's a very good enterprise scale solution that provides a really high quality service at around about, well less than half the price of an equivalent commercial service. And finally there we've got the data pipeline, and that allows us to process and move data between different applications, and it orchestrates a lot of this stuff for us. And behind that is clusters of compute capacity that make that happen.
Okay, so let's have a go at using one of these management tools. So as we stated before, we're going to create a billing alert that's going to send us an email whenever our costs are exceeded or estimated to be exceeded. So the way we're going to do that is that we're going to use the AWS Management Console, and we're going to enable billing or billing alerts within the Billing and Cost Management Console. And then we're going to create a metric, a CloudWatch metric, that is going to monitor those billing costs. And when they exceed a certain limit, then that will notify, or the CloudWatch service will notify an SNS topic to send us an email. Okay, from the AWS Management Console, the first thing we need to do is that we need to enable billing alerts. So we go to our account menu and we go to the billing dashboard. And when we're in the billing dashboard, just go on to the left-hand side here to Preferences. And we just need to make sure that we have checked Receive Billing Alerts and save those preferences. And then go back to the console. Now what we need to do is that we need to go into CloudWatch and we need to create a CloudWatch alarm that is going to trigger whenever these costs are exceeded for the month, or the estimated costs are going to be exceeded. So we go into Services, and then we look into the Management Tools, and we'll find CloudWatch. And then we just jump into Alarms, and we need to create an alarm. Now we've got a number of metrics here that we can use. The ones that we're concerned with are the billing metrics, but we have a whole heap of others there, and we'll talk a lot about those going on into the course further on. But for now, we're just going to create a billing alert. So we're going to use the total estimated charge as a metric. So when we set a limit on that, if it goes over it, it will trigger an alarm for us. So we'll just click on that. Now what we need to do is, we'll just go down to here, is we need to select that metric and then we click on Next. We give the metric a name. And what we need to do now is that we need to put in a set point there. So what is the point where we want to be receiving an email that there is a problem? So if it's, $1,000, is it $100? Or maybe we start off with $10. So we'll just make it there $10. So when our costs are looking to, our estimated costs are looking to exceed $10, we'll receive a email from the SNS service actually. And just scroll down to actions. So what we need to do is define what actions are taken when this alarm changes state. So what we want to do is that when there is an alarm go off, we want to send a notification to, and we're going to send it by email. So we're going to click on a new list, and we'll give our notification topic a name, and then we'll put in our email address. Now once we've done that, we can create an alarm. Now what's going to happen now is that we will have a notification that we've subscribed to a SNS topic, and that we need to confirm that we are going to subscribe to that SNS topic with our email address. And so what's basically happening here is that we've created a CloudWatch alarm. And at the same time, by doing that, we've also created an SNS topic. And this CloudWatch alarm is going to notify this SNS topic, and when it does that, the SNS topic will send out an email, or the SNS service will send out an email to us to alert us that there is a problem with this CloudWatch metric that has been exceeded. Now when you receive that email and you click on the link inside that email, you will get this page saying that the subscription has been confirmed. So that's looking pretty good, so I'll just close out of that. Now back in the management console, I'll just close out of that, or I can actually now view the alarm. And it's saying pending confirmation, but if I click on that and if I refresh the screen, it's now all ready to go. So now we've actually created that monthly billing alert, and it's there up and running, and we can see there when the estimated charges exceed 10 hours for 6 hours, we're going to have an email sent out to us. How do we know there's an email? Because we can go into our simple notification service and check. So let's do that. So we go into services and we go into simple notification service. So I just listed them there alphabetically, but it'll be in the messaging area here. So simple notification service. And now we can just have a look at the topics now. And we can see here we've got a topic that's been done there. So let's have a look at that. And there we can see there is our monthly billing alert topic. Okay, so we'll just finish up there. So you've done quite a bit. We've gone through quite a number of very short and quick labs. So you'll be getting more and more used to the AWS Management Console and some of these services and how they all interact together. Now, we're not going to tear this one down and clean it up because we'd like to keep it there because I think it's a good idea to have billing alerts. So we'll just leave it up and running, and every time that you are looking to exceed your monthly cost of $10, it'll send you an email and you can change that, and decrease it or increase it or whatever you want to do. So I'll see you in the next section. And welcome back to Backspace Academy. In this practical lab on highly available and fault-tolerant Node.js servers, we'll look at creating, using the AWS Elastic Beanstalk deployment service, we'll look at creating a highly available and fault-tolerant architecture for deploying our web applications. Once we've done that, we'll then look at using this architecture to deploy our code and also use Elastic Beanstalk to manage how we release new versions of our application to this architecture. So this architecture is going to be very, very complex. It's going to have Elastic Load Balancers. It's going to have EC2 instances in an auto scaling group. It's going to have all of the nuts and bolts that need to go into that. It's going to have route tables, network access control lists, whole heap of stuff. But the good thing is we don't need to worry about that. Although that's going to be created, the Elastic Beanstalk service is going to create that for us, which is really great if you're just starting to learn about AWS, or you just don't want to learn too much about AWS. You just want to get to the finish line without having to go through all the nuts and bolts stuff. And Elastic Beanstalk, it'll let you do that. It'll allow you to just supply it your code, and it will launch this environment for you. And when you've made changes, you've got a different version of your code, you just supply that to the Elastic Beanstalk service, and it will deploy and update that code to all of these EC2 servers that are out there. So let's have a look at that. Okay, so here I am in the management console. We get to Elastic Beanstalk again through services. We go to the compute area and select Elastic Beanstalk. If we haven't created an Elastic Beanstalk environment before, or an Elastic Beanstalk application, we'll be presented with this welcome screen. We don't need to worry about that too much. We're just going to go up into the top right-hand corner here and click on Create New Application. We'll give our application a name. And we won't worry about giving it a description. So we've just started our backspace-intro application. For it to work, it needs to be able to be launched onto something, and it also needs code. So we need to be able to create an environment or an architecture that will consist of all of our servers and our load balancer and all that sort of stuff. And we also need to upload our application code as well. So for this, we're going to launch an environment, and we're going to use the AWS sample NodeJS code for that, and then we can play around with it. We can download that, and then we can change that a little bit, and then upload a new version of that Node.js application and see what happens. So for now, let's just click on where it says no environments currently exist, and we'll click on create one now. We're looking to create a web server environment, and again we'll look for a domain for this. I'm just going to type in backspace, but yours will have to be different, of course. And that one's available for me, so I can use that. I'm not going to worry about putting a description in. Now we're going to use a pre-configured platform, which will be for Node.js. And for our application code, we're going to use a sample application. It's a good idea to use a sample application because your environment will get up and running very quickly, and then all you need to do is deploy your actual code that you're going to be using onto that environment afterwards. So that looks fine right now. So the only thing we need to change is we need to go into configure more options, and we need to make sure that it's a highly available architecture. So by default it says low cost, free tier eligible, but we're going to go for high availability because it's going to be a production server environment, and so we'd like to have that highly available. We want it to have our instances across multiple availability zones if one of those availability zones goes down. And we also want to have a load balancer that distributes traffic across those availability zones, and also performs health checks on those servers so that if one server goes down, it'll replace it there for us as well. And now we just scroll down to the bottom here and we just click on Create Environment. Now, what will happen is that the Elastic Beanstalk service will now go through and it'll start creating this environment, and it'll create our EC2 services, it'll create our auto scaling group, it'll create our Elastic Load Balancer, and it'll create all the routes and network access control lists and everything that needs to happen for that. And we don't need to worry about anything. And eventually it will come up to say that the application has been successfully launched. And after quite some time, we'll get this success screen, which is great, a big green tick. If we scroll down here and we just click on Show All for these recent events, and we can see exactly what happened. So we're now at the stage where we've got the environment health has transitioned from pending to OK. So that happened at, 3:08. And if we scroll down even further, we can see it was at 3:05. So it's taken about 3 or 4 minutes, and we've created that environment. Now, if you're going to do that manually, that would be at least a half an hour job to go through and create route tables and all this sort of stuff, and wouldn't be a quick process. So certainly it saves us a lot of time. So now that we've created our environment, and it will have the AWS sample Node.js application on it, we can go to this URL up the top here, and we can click on that, and it'll take us to our application. And there we can see, congratulations, your first AWS Elastic Beanstalk Node.js application is now running. So what we're going to do is we're going to download this application, and we're just going to change it a bit. We're just going to change the color on the side here so we can see that the new version has come across. So it's jumping back into the console again. If we go back to our application, backspace-intro, so back up here, and then we go to application versions. And we can see here we've got our sample application has been deployed. So if we click on that, and it takes us to the documentation which will have the Elastic Beanstalk resources. If we scroll down here, we will find here we have the Node.js sample application in a zip file. So we just need to download that. And once we've downloaded that, just unzip it to somewhere. Okay, so now that I've downloaded that sample application, I can unzip it. And what I need to do is just get that index.html file inside of that, and just going to edit it. Okay, so I'm just now got the index.html file in Notepad, and just going to scroll down to line 38, and we can see here we've got the background color for that text column. Just going to change that color to magenta, and then I'll just save that. So once we've modified that index.html, we just grab all of these files that we've unzipped, and we'll just add those to a zip file. And there's our zip file. So we need to go back into the AWS Management Console, and we need to upload this new version of this application and see what happens. And back into the Management Console, we click on Upload. We just give this a version name. We'll give it version 2.00. That'll do. We won't bother about a description. And we choose our file. And upload our file. And if everything goes fine, we'll have this here. So all we need to do now is just select our new version, and we deploy it. So just click on Deploy. We select our environment. We've only got one environment there, and we'll select that, and we'll deploy it to that environment that we created. So that's all happening, and we can see there's a message there saying that it started successfully, and we can go to the events page and see what's happening. And then we can see we're deploying a new version to the instance. And when it's ready, it'll have a success screen. Okay, so our environment has transitioned from OK to info, and we've got our new version of our application deployed onto our environment. So again, if we go to our URL up the top here, we should be able to see our new version of the application. And there you can see it's uploaded that, or it's deployed that new version of the application to those server instances, and it has a magenta background. So that's how easy it is to launch a quite complicated, highly available and fault-tolerant architecture, and then use that to deploy your Node.js application, and at the same time deploy updates when needed to that application. So that brings us to the end. So all that we need to do now is to go through and delete everything that we've done so that we don't get a big bill. Make sure you do this step because this is going to be a multiple availability zone environment. So it will have a lot of instances there and a lot of costs will be incurred if you don't clean it up. Okay, so the easiest way to do is to go into our backspace intro application. And we just go into Actions, and we delete our application. When you do that, it looks like nothing's happened. So all you need to do is to go back into the backspace intro environment, and you will notice that it says Elastic Beanstalk is terminating your environment. And again, you can go to View Events and see what's happening there. And when it has successfully terminated your environment, you'll be back to the welcome screen. So that brings us to the end of this lecture, and I'll see you in the next one.
And welcome back to Backspace Academy. Throughout this course, we're going to be using a lot of different AWS services, and normally that would incur a cost. So I'm going to talk about the AWS Free Tier. And what that does, it allows us for a period of 12 months after we first sign up for an AWS account, it allows us to use a lot of these services that we're going to be using throughout the course, to use those for free within certain limits. Now the AWS Free Tier, it's designed to enable you to get hands-on experience in using the cloud, and it enables you to do that for free for a period of 12 months. Now with anything, there's going to be terms and conditions. There's going to be limits within which you have to operate. So it's going to be valid for 12 months after you sign up for AWS. So that means that if your account is already 12 months old, you're not going to be able to take advantage of the 12-month free tier. And also some of the services are even less than 12 months. Some of them are only 2 months, for example. So if you've got an old account and you're going to use one of these services, you might get a bit of a surprise at the end of the month on your bill. Usage limits apply. If you want to create the next Facebook using the free tier, that's not going to happen. So this is for small instances and small services for R&D purposes mainly. It's not available for all services, but you can get more information on what is available at aws.amazon.com/free. Now within the compute category, the services that we'll be looking at mostly in this course and will be on the free tier will be EC2, Lambda and Elastic Load Balancing. So the thing to look at there with EC2 is that you're going to get 750 hours per month of Linux or Windows, and that's going to be on a T2 micro instance. So if you run a T2 micro for a month and you're on the 12-month sign up and that's the only instance you're running, then you will get that for free. One thing to consider though, obviously if you go for a bigger instance, you're going to be paying for that. But also if you go for a smaller instance, if you go for a nano, you're still going to have to pay for that. So this is only for one specific instance type, being the T2 micro. In the storage area, again, we've got some good services there that we'll be taking advantage of on the free tier. We've got Amazon S3, Elastic File Service, we've got CloudFront we'll be using in the next section, and Amazon EBS, which we'll be using in the EC2 section. And that all of those are available for free within limits, and those limits there will be on the Amazon web page. I'm not going to read that out to you here. It's all available on the AWS web page, and it is updating regularly. But that expires after 12 months after sign up. Now we have a range of database services that are available on the free tier, but we need to be careful when we're using these because some of them don't go for 12 months, some of them only go for 2 months, and some of them, like with EC2, they only work on a T2 micro instance, they don't work on a nano instance, so you need to be aware of that. So with RDS, again, like with EC2, that's for a T2 micro instance. It's not for a smaller instance or a bigger instance. So make sure that you use a T2 micro if you want to get it on the free tier. Another thing to consider there is when you look at these expensive databases like Amazon Redshift, that is only available for 2 months after sign up. So if your account is already 2 months old, you've missed the boat on that one. Or if it's 1 month old, you want to be very careful when you stop and start that instance, because this is a very expensive service, Amazon Redshift. It's an enterprise scale service, so you don't want to run that just for R&D purposes unless you're getting it on that free tier. In the application services, they operate a little bit differently on the AWS free tier in that they don't expire at the end of that 12-month period. So when we look at these services that we're looking at here for SES, SQS and SWF that we'll be using within this course, those services won't expire after the 12-month free tier. They'll still be free within those limits. So those limits you can see there for SES are 62,000 outbound messages, and you can see there for SQS and simple workflow service as well. So provided you stay within those limits, you're fine, and you don't have to worry about what happens after the 12-month free tier term expires. And the last one we just look at there are the management tools that we'll be using is CloudWatch. So again, that has limits to within which we have to operate, and that doesn't expire after the 12-month free term. But AWS Trusted Advisor, that will expire, the free offer there of 4 best practice checks, that will expire after 12-month period is up. So if you want to use a Trusted Advisor, make sure you do that within the first 12 months of signing up. Okay, so what happens after 12 months? You've had your account, you've gone through this course and you're still using it, and your 12 months has expired, and you really just don't want to keep paying for it. You just don't want to have another bill to keep track of and that sort of thing. So what you can do is, if you just want to keep an account available just for R&D purposes, you can create another AWS account using a different email address and then link that to your main account using consolidated billing. And that will set that up as a child account. So you still just have one bill that you'll be paying for through your main account, but this second account that you've created will enable you to continue to use the AWS free tier, provided you do everything within that new account. On your old account, your main account, that will still be expired as far as the free tier is concerned. So that's a way to kind of keep on going if you want to just keep playing around with AWS without having to absorb a big bill at the end of each month. So again, if you want to find out more, just go to the Amazon website, aws.amazon.com, and go to /free, and you'll see what the latest news is on the free tier, because it is changing regularly. I'll see you in the next lessons.